Everybody, this is Mr. Schultz back with you. We're taking a look at 713, and we're just going to keep working on this unit circle and how it translates to the graph. And it's kind of that back and forth, that screamer question, the roller coaster from 711. So if you're just jumping straight to this video, some of this context is probably going to be a little bit weird. I would read a little bit of that intro in 711. But let's get started here. So here in 733, it says, draw a circle on your paper, then draw a triangle that could represent Renee and Antonio's position on any um, position on the wheel when the screamer, that's the roller coaster, came to a sudden stop. Should choose a different angle position from any of those you drew in 714. So that's referencing last lesson. You can also use the student E tool. So that's what we're going to do. So label the triangle with its height and its angle measure. So let's take a look here, see how awkward I can be when I am trying to click on this stuff as we are going here. So here is our here is uh our stuff here. So here's a student e-tool. So we've got our circle here. Our circle is this guy right here. And then we're going to be able to drag this slider here, and that'll change and go to any position. So you can see that goes down to, or it goes up to 360. So this will go all the way through and create triangles the whole way around the circle, and even go down to a -10. So it could go backwards a little bit here too. But let's take a look at what this looks like here. So we are going to click here. This thing is kind of weird. It says you can double tap, but I don't really believe it because I'm trying that. So there are the different triangles. So when we started from last lesson, we had that 30-degree triangle there, which was at that 0.5, and just kind of creating that. But it's saying you can go and you can draw any triangle here. So we can go all the way back down. There's that -10. Go all the way around the triangle. You know, if they got stuck underground, if they got stuck on underground over here, anything inside there. So you will draw the circle and then draw that triangle, and label the height and the angle from its measure. So here, let's say that I decide to use, I don't know, 135 degrees here. So then I could click on here, and that would be my different height and the measure. So the X value is how far over, the Y value is going to be how far up it's going. So this is that height there. So in that part A, label the triangle with its height and its angle measure. So here, this would be 135 degrees, and its height would be this 0.70711, or just 0.707 is awesome. That 0.707, that's a kind of common number that you'll see pop up in these triangles a little bit here. So that is that, which actually I think I just chose one that is kind of the normal. Did I? 40, yeah, I chose a 45. So there'd be a 45-degree angle right there if you went from the 180 line there. So I probably should choose a different one just to stay true to the question here. So let's go, I don't know, let's go 173. So then here, the angle of the triangle there would be 7 degrees. So I'm going to write that down here on the side. So I've got 7 degrees, and then my height is going to end up being at point 1, 2. We'll just call it 0.121. I think that's great. So that's that height, and that is that angle. You also could use this 173. It kind of means the same thing here. So we'll just get both of those down, 173. So that's part A. Now it says, let's take a look at part B here. So part B, getting this double tap going on here. So it says, did any of the riders have to climb the same distance to get to safety as Renee and Antonio? If so, draw the corresponding triangles and label them appropriately. So on this one, in theory, if we're talking about that 7-degree thing, well, then we need a 7-degree triangle going this way. We need that 7-degree triangle, which that's clearly 7. Let me try that again. Let's do a different color here too, just so we can see. So 7-degree triangle going that way. And then we've got a 7-degree triangle going this way. So there would potentially be a 3 other rider spots that would have had that same distance to climb that they do. And so then it wants you to draw them and label them and label them accordingly. I'm going to erase these drawings now just so that we can move this angle so that you can see here when I take this and I take it back down to that 7 now, which should see if I can get there. Oh man, this thing's oh good. Now when I click on this height, hey look, that's that same number that we saw from beforehand. That same 121. That's that same 1221. That 173 and that 7 end up being that same number there. Let's check it out with some of the other ones. So when we had that kind of -7 1. Let's see if I can grab it. There we go. If I click on that, hey, 121. And then of course we just gotta roll out to 187 here. So far, I've been getting pretty good at this. And I jinxed myself here. Let's call 188 the same thing. You can see it's just slightly off there. But of course, if I was able to get to exactly 187 there, let's try it one more time here. Nope, it's just not gonna like me. But yeah, it's gonna all be the same 121 number. So we're seeing these points. Whoops. We're seeing these 7 degrees kind of off of these things that are all producing the same values in the heights there. So what is the relationship between these triangles? Well, they're all going to be similar or I should say congruent triangles. They all have this same angle right there. They all have a right angle right there. So therefore you've got two angles. So by angle, these things are going to be congruent triangles. So by angle, well, I should say that angle, it would be for similarity. But then we also know that the height here, that the height that the height is all that same. We could also check that distance. So then you can start to get into your side angle side. You could get angle side angle, like anything like that. But in this case, we've got them all. They're going to be congruent. So that's our key thing here is just that any triangle that we can produce on this side here is going to have a counterpoint here, or I should say not a counterpoint, but a counterpart here and here in all of the other quadrants. So you'll see that from each of them. So let's jump on to our next problem and see what our next part is here. All right, team. So here we go on the next one, 734. So it says use the lesson resource page or the student e-tool. That is an arrow in somebody's lifetime. Let's try this again. There's an arrow. To find the height of the seat that is rotated 130 degrees from the starting platform, you can click the lower right or just click on the link. I have the link right here, so we're gonna take a look at it. So get that link going here, and I'm gonna pull that up right there. And so here, what I am gonna do is I'm just gonna try to get this sine graph to make it to 130. So here it says hint, click and drag along the graph. So you can do that, but getting and holding on 130 is kind of annoying here. So it is possible, but it's just kind of annoying. So one of my hints to you here is just create another row, x equals 130, and there you go. Now you got yourself a consistent dot that you can click on that'll intersect there. So find the height of the seat that has rotated 130 degrees. Well, we've got it right there. We've got the height. So the height there would be equal to 0, or excuse me, yep, 0.766. I am just gonna round that off to the thousandths place. I usually round to the hundredth place, but I just find that when you're doing sine stuff, that going to the thousandth place just makes a little bit more sense, sine or cosine, but you'll see that in a bit here. So that's our part A. So we've got our part A here. So now we're down to part B. It says, are there any other seats that have exactly the same height? So we are just going to look and go, hey, if I'm to draw a line across here, I can tell that there's for sure going to be another one, probably right over here someplace. Then hint, hint, this graph keeps going. So right over here, we're also going to find some that'll be that same height. We saw in the last one that there are some that exist down here. So this number, but just in the negative land. So I don't know, like right about here-ish, you'll have some that'll pop up like right here and here, but those are technically negative values, so they aren't quite the same, even though as far as Renee and Antonio's escape goes, they would still be climbing the same distance, but they're looking for the same height. So we'll just call it that it's just these two. So we need to figure out what this angle is here. If so, indicate them on the page here. So I'm going to go and I'm going to erase all this so we can actually see what's happening when I start to move this graph here. And so I'm going to go and I'm going to get another X value here. And so if I'm thinking 130, well, 90 is that halfway point. So I'm going to try to go about 40 degrees or so let me just, instead of just saying this, let me show this. So if I'm at 130 and 90 is at that peak, so then that's about 40 degrees off of 90. So what I see that being is if I get a new graph here, I'm gonna go X is equal to 50. And that's gonna get me that same coordinate there for both of those. But it's just got the different value because it's in that first part of the unit circle there. So there is another one that has the exact same, that'd be 50. So this is part B. So a 50-degree angle does. You could also find them out down, like I said, down in the negative, but we'll just stick with the one with the positive values for right now. So that's that. Then we'll jump down here to part C. It says, how can you use the symmetry of the graph to calculate which angles correspond to seats with the same height. So that's kind of what I talked about in last one, going, hey, this one was 40 degrees off of my 90 and 40 degrees off of my 90. So there's that kind of symmetry thing. Same idea here. If I get down to 270 here, well, that's kind of like what the 90 is up here. So if I go 40 degrees off of 270 here and 40 degrees off of 270 here, you can get that same value, but of course in that kind of negative region there. So just kind of something to think about here. And then our last thing, for each of the following angles, use the sine calculator from the resource page to find the height and angle, and to find another angle with the same height, then sketch a small unit circle, draw in each pair of angles, label the height. Okay, so we're given this number and we're trying to find what's another triangle that fits that piece there. So I'm going to try to get this to size well for me so that I got some space here. So I'm going to start off here, and this is now part C. So, or excuse me, part D, and we're going DI. So this is for my 80-degree piece. So what's another triangle there? Well, off of my 90, that's only 10 degrees off. So I'm assuming that the triangle at angle 100 is going to be one of those spots. So then I'm going to check that by just going back into my calculator here. And let's actually just do a row down here, but I need to see it. Let's see here, slide this back over because I need to see my keyboard. Hit on that. Come on, buddy. Be good to me. Now I can't write. This is the type of stuff that you just love to see. Okay, well, it's gonna be terrible for me. So I'm just gonna back this up to 80 here. So I've got my 80, and then I'm gonna set this up for x is equal to 100. And I'm going to compare these 2 points here, and sure enough, I've got that same piece there. So looking back at our stuff here, I'm supposed to use the sine to find the height of the angle, to find another angle at the same height, then sketch the small unit circle and draw the pair of angles. So the height here, I'm just going to get from my calculator. So that's that 0.984, we'll call it 0.984. I probably should round that to be 0.985, but doesn't really matter too much there. So that's that height. So if I'm drawing my unit circle, and I'm going to have one of these that's going to be at 80 degrees like this, and it's got that height of 0.985. I'm going to have my second one that's going to be over here, and it's also going to have that same height. This is at angle 100. This is at angle 80. So that's really what they're trying to get you to see there. So I'm not going to do the next three because I think that you guys are super capable of kind of following that. But or excuse me, the next two. So you've got one at 200. Try to find that one. Try to find that one, and then pause the video, and I'll show you what the answers are in just a second. All right, and there you go. You've got yourself this height of the seat, which is negative 0.342, and then some other decimals that should be at angle 200 and angle 340. And then you've got your next one here, negative 0.766, and that's at 230 and at 3. Okay, so that's kind of everything. The last problem is a learning log. So let's take a look at what that is. All right, so with your team, discuss ways in which a unit circle in the graph of s of theta is equal to sine of theta are connected. Be prepared to share your ideas. So here are the big things. We see this unit circle, and we see this sine graph that looks something kind of like that. And so when we've got that, we've got this angle here that corresponds with this angle here. And these 2 points correspond with the same 2 points that are happening right there on the graph, or depending on where it is. And we see all of this levels of symmetry where we've got this same kind of height. We've got the same kind of seat or distance here. We've got these same angles. If you look at that angle as compared to that angle, lots and lots of similarities there. So just know that just here that this angle here corresponds with that angle, and that this angle, because this is because the x-axis in this case is done in degrees, um, and then this would be your height, would be your y-axis here, and so then this angle is corresponding with that angle. As you get over these kind of key points of these 90 degrees, these 180, 270, and then of course here would be 360, which then starts to cycle back through and match up again with your 0 point here. So these are kind of your key points here that are getting you around the unit circle. As it goes around here and does this, it's creating these same points here that just keep going in that kind of up and down wave there. All right, that's everything we got for this lesson. Let me know if you have any questions. I'd love to hear from you.